I think this is now the moment in time that this kind of new era of deploying applications and workloads and services is really starting to become applicable to absolutely everybody. I think it's the new era of cloud coming together.
This is DevOps Paradox, episode number 210, Mastering Database Scalability with PlanetScale. Welcome to DevOps Paradox. This is a podcast about random stuff in which we, Darren and Victor, pretend we know what we're talking about. Most of the time, we mask our ignorance by putting the word DevOps everywhere we can and mix it with random buzzwords like Kubernetes, serverless, CI/CD, team productivity, islands of happiness, and other fancy expressions that make us sound like we know what we're doing. Occasionally, we invite guests who do know something, but we do not do that often since they might make us look incompetent. The truth is out there, and there is no way we are going to find it. P.S. It's Darren reading this text and feeling embarrassed that Victor made me do it. Here are your hosts, Darren Pope and Victor Farsick. Victor, as we spend time building just silly little websites, do you think about scaling those things at all, or do you just think about, if it's up, it's up, if it's down, it's down?
Those silly demos, no. But then when it comes to real job, yes.
And of course, scaling is just a magic easy button, isn't it? You just push a button and everything goes forward.
You just add 57 additional replicas and you're done. Maybe 60.
Maybe 60, but that's only good if that region doesn't go down.
Yeah, and you spread it all across 75 regions, and that's it. And 3 cloud providers.
And that's it.
Exactly.
That's all there is to it.
15 minutes.
We're joking about this. We know scaling is hard. And on today's show, we've got Sam Lambert on from PlanetScale. Sam, how you doing?
I'm great, thank you. How are you guys?
Very well, thank you. Let's talk scale, because you worked at some companies in your past that some people may or may not have heard of. There's just one little thing called Facebook. And, a couple people have heard of that, I think. I've sort of lost track. And then there's this code thing called GitHub that, that's, a couple people use that, I think, right? Because last I heard is 100 million users or something. Just a few. You've worked at really big places. We're trying to cheese it up a little bit. How do companies like that think about scale?
I think scale is interesting. And I think a lot of people define scale and scalability very differently. I think it's being able to do what you do well and repeatedly n number of times. So the Facebook database team, they say small data. They talk about small data, right? Because what they've done is they've taken a small cluster configuration and they've scaled it up a very large number of times to meet the needs of their user base. The kind of key to scalability is doing simple things repeatedly and making those units of scale as autonomous as possible, and essentially just keep growing to meet the demand of your user base and the peaks and troughs of those user base as well. So scalability is a really interesting practice and kind of dimension of what we have to do within the tech industry. And I think it's one of those things that people don't think about until it bites them. And then when you're hitting scaling problems and you're failing at scaling problems, you're failing to grow or build your business.
When you're talking about repeatable, and let's think back, just play out the Facebook thing there without giving away anything. What is small data to Facebook? Are we still talking terabytes?
Well, there is data sets at Facebook that are many exabytes, and scale of data at Facebook means something completely different to the rest of the world. But I think a lot of the time they think in the scale of individual users' data, right? And what can fit on their shard or their cluster, and how to provide that same experience and that kind of architecture repeatedly over and over again for pretty much the entire social graph of the entire world.
So it's more about really scaling horizontally in a way than what we had in the past. When enterprise companies were planning, okay, can this one database instance support XYZ, whatever XYZ is, right?
Like real horizontal scalability, if you can get into a place of that makes scaling much more linear and much more predictable. So one of the benchmarks we released is about 1 million QPS. And that's cool. That's a really big number of queries per second. The thing that's most interesting to us is that a doubling of machine size is a doubling of throughput. And not many software stacks, especially databases, actually get to that stage. And that means being predictable is difficult. And when you're at massive hyperscale, you have like years of just hardware planning to do to get over the new peak that you'll hit that you'll probably never go back down from, right? And so having software systems that scale that way gives you much more predictability. And that's kind of the predictability that trickles down that every one of us would want, right? Like if you speak to most people and you say, how much life does your MySQL master have left in it? They don't really know. They could say, well, it's at 50% utilization, and so we could potentially double. That's never true, right? Like even within the MySQL process or within a single server, it doesn't quite work that way. And so if you can shard and build a horizontally scalable database system, you get much more predictability for your stack and scaling your business.
And also, I'm assuming that from that perspective, also the work required to double something is not double, right? It scales. It doesn't equally scale the effort.
Low marginal human cost is something that we talk about, right? Like, and that's again something really, really important because you just can't keep hiring engineers. I mean, your business metrics don't work if you even do that, but growing your stack should be as simple as possible and more. And that's the beautiful things about software, right? And SaaS businesses and all of these things is that small amounts of humans can manage colossal infrastructure when you get your software to scale. But it takes being deliberate and trying to do things that are scalable and thinking with scalability in mind. And it's relevant to everybody. At any scale, things should work appropriately well, and things should be appropriately priced and should have appropriate human toll to them.
You mentioned there years of hardware planning. At PlanetScale, what does hardware planning look like?
It looks like making more commits to Google and AWS, and kind of modeling and also just like improving our systems. Our engineering team are fantastic, and they've been making the system much more efficient. So like it takes less computers to serve what we serve for the many databases that we look after. But yeah, we run primarily in the cloud. At GitHub, we run in the data center as well, and we got that provisioning machines and kind of growing our hardware footprint. We got that to probably being as simple and easy as possible, but it still had its overhead, right? Like with AWS, we've got a little bit more freedom there, and that's the beauty of cloud.
So at this point, PlanetScale, at least early 2023, is all based in the big three hyperscalers? Or all three, or multiple other hyperscalers if you don't want to give away too much there?
Yeah, we can run on any cloud. We believe fully in the cloud. I wouldn't do a kind of on-prem deployment of PlanetScale. One, it's extremely, our stack is very cloud native and needs a lot of the primitives that the cloud provides. And also, we can't provide the experience that we provide for our users without being in the cloud. We just couldn't do it for them in the data center. We take full management ownership of the database, and that's really a cloud dependency.
Are you seeing the move from Intel-based workloads to AMD-based workloads? Does that make a difference to you from an operational perspective?
So where we are, actually, I think we've experimented with AMD. It's again another savings method, but I'm not sure where we are with that work. I haven't actually focused at that kind of granular level. We are seeing lots of people moving out of data centers to the cloud. That's just another migration that's still still going, no hold up there. And it's still very early. I mean, there's estimates that say only like 10, 12% of the workloads that could be in the cloud are in the cloud. So there's a huge migration that's happening.
And that's usually where Victor would jump in and is like, everything's already in the cloud.
No, I never said everything is in a cloud. What I do say when speaking with other companies is that on-prem pie is not going to be increasing. It can, at the best, stay the same or be reduced. and I'm now being open to all variations, but those are all the variations. Stays the same or shrinks. So to me, kind of, unless you're in a very niche type of market or you're already well established on-prem, it makes almost no sense to start business there.
I think that's the narrative. I think a lot of people, though, I mean, there's a lot of job protection by staying on-prem, right?
Mainframe.
Sysadmins or people that, yeah, right. I think first of all, it's a long migration. And I think a thing companies are getting wrong is they're not migrating to the cloud. They're just like uplifting their bad data center decisions into the cloud, which is very, very different. And then people are comparing, well, it's just more expensive than the data center. And that's just like, well, I mean, you're not using value add services. You're not using the best of the cloud. You're not using all of these things that make the cloud really fantastic. So the cost of ownership is not changing. Companies that are truly getting it right will never think about the data center ever again.
I dare any company who is really using cloud with all its potential to come up with a sentence that says that's more expensive than on-prem. And when I say more expensive, I mean not only hardware you're buying, but people you're employing additional, but only and exclusively when you do it right? If you just say, I have 100 servers in on-prem, and I want to have 100 EC2 instances in AWS, makes no sense. Of course, it's going to be more expensive and no tangible benefit whatsoever.
Unfortunately, it's what people are doing. That's what happens.
Yeah, I mean, to be honest, I was more negative towards that in the past, and now I'm thinking that maybe that's a necessary step that companies have to take to actually realize the potential. Maybe I was too optimistic in the past when I was thinking, hey, you should actually go from on-prem to cloud in a good way. Maybe you need to mess it up first.
Yeah, at least you're starting. These are the types of the deployments that trip into things like latency, or latency in places they've never had before, like between disks and servers, and between applications and databases. It's that again gets really painful when people try and put these workloads in the cloud. But it's a good evolution. It's a beginning.
Exactly, especially for what I'm most negative around that subject is when companies think that they can just run their applications in cloud. Those that were not designed with their databases and their applications and their this and that, and just kind of moving to cloud is just a silly idea, if you ask me. Redesigning applications and what's or not to run in cloud, that makes perfect sense, right? It can take 10 years, but then that starts making sense. I mean, if I take it extreme and say, hey, we're going to move mainframe to cloud, and I know that I'm taking extreme now, why? What's the point?
Is there a point to where it would make sense to just stay on-prem, since we've gone down this rabbit hole? Why would somebody not move to one of the hyperscalers?
If you're running a high-frequency trading platform, potentially would be good for you if you need access to the PCI bus or something for all the weird, crazy things they do with these platforms. I think most people have absolutely no reason to. With GitHub, the way our workload was, and because of our timing, when we were built, the cloud wasn't what it was today. And we ran, obviously, pretty much the entire world's code on physical machines. And Git is, extremely chatty with disks. It is very, very I/O bound. And getting that workload into the cloud would have been very, very expensive to do. We were able to buy NVMe in the data center, get blisteringly fast disk access. So the Git workload was kind of one where data centers seemed to make sense, and we were just kind of storing tons and tons of data, like similar to the Dropbox story of moving out of the cloud into the data center. But hardly anyone is Dropbox or GitHub or whatever. If you have those niche needs, staying in the data center is completely fine. For everybody else, and for everyone else to give themselves the chance to have those problems, you should be on the cloud, iterating and building really, really quickly. And that's where the promise of DevOps is.
I go even as far as to say that it might make sense for people to run on-prem, but only after they've been in cloud. Meaning after you understood really what is today's expectation from such services, what you should really have. And then, make an educated decision. Can you replicate the services that you're currently using, right?
Because if that at that point it's financial optimization, and I'd assume you've done quite well as a company. And if those are the problems you have, be really grateful for those. But it's not the place to start.
No, it's definitely not the place to start. So if I'm understanding both of you correctly, initially I'm on-prem, and I should go to cloud, give it my best. I might lift and shift day one. I might refactor to be native, if you will. And then if I find that that's costing me too much money, then that's when I would consider potentially going back to on-prem.
For a very small percentage. For Netflixes of the world, yes.
Yeah, Netflix is an interesting example. People talk about them as being cloud deployment. I mean, yeah, if you consider they also run a physical CDN that is one of the largest in the world on physical machines they manage themselves. I mean, yeah, they're in the cloud. But when those are the types of optimizations you have, you should be, but no one gets there. Very few people get there. And you shouldn't start there. Like that, the case you discussed, they started in the data center and they moved to the cloud, maybe they go back. Very unlikely people will go back. Most of the time, people should start their businesses using the cloud. And I think most people do. I think most net new has to be in the cloud, surely.
I would have a very hard time imagining a startup that is really a startup and saying, I'm going to build my own data center. I would actually like to be present in such a conversation with investors.
I've heard of it. I've still heard of it as recently as last year, but it is very rare. It's still very rare. I think within the cloud, though, people make some bad decisions still. They choose unscalable cloud workloads that don't necessarily have the trade-offs. Like, I think this serverless era, this new era, is actually the most exciting because the end experience for people building new products is now getting so good on top of technologies that are very, very scalable. Remember, you used to say, well, you're starting your project, you're not scaling, don't over-engineer. Now, the chance of factoring in scale without over-engineering is better than ever. The chance you could do that is much better than it's ever been.
I understand, or I think I understand well what serverless means for your own personal applications, right? I don't manage servers myself. Things automatically happen, and my application will scale either for each request or each 100 requests or this criteria, based on some criteria, right? Again, not my problem most of the time, right? How does that translate to databases? What is a serverless database?
So people have lots of different opinions of what it means to be a serverless database. The fundamental properties you just talked about of serverless are still there in a serverless database. It's a bit harder with databases. The way we look at it is, one, you pay for what you consume. So we meter your queries. We don't make you provision vCPUs or memory or whatever and allocate that. You kind of pay for what you're using within your application. And that's all we charge. And you kind of, for me, it's about a design philosophy. You're not coming to buy servers. You're coming to consume and pay for the value that you get from that product. It's all about the experience of what the database is there to do, which is allow you to read, write, update, and delete your data without you thinking about managing servers and thinking about clusters and replicate. You won't see the word server or cluster in our UI because you can just create a database and then do things with the database that you would usually do. And then you are charged for the amount of times you do that.
So imagine there would be, and you could probably come up with many others, or correct me immediately, there are cases where people have high traffic or high read-write to databases, right? Potentially big volume. And then there is a case of maybe potentially big volume, but not necessarily high activity. Does both is the serverless database at the end of the day for everybody? I'm jumping all over the place. Who should not go for serverless database today? If anybody.
I mean, nowadays, I think it works for everybody. We now run some absolutely giant workloads, like brand names that, if I was going to disclose who they are, everyone would know these. Like, there's two apps I use pretty much routinely at least 3-4 times a week, all running on PlanetScale, massive top 20 iPhone apps. I think it's there for everybody. I think this is now the moment in time that this kind of new era of deploying applications and workloads and services is really starting to become applicable to absolutely everybody. I think it's the new era of cloud coming together.
So take me back to the first week you were at GitHub.
First week I was at GitHub, I broke the website, which was a really terrifying experience that I'll never forget. But it was a great week. I joined this company that at that time, this was 2013, was this kind of young, incredible, crazy company that was just exciting everybody in the world. And we had scaling challenges. And I think the thing that impressed on me that I've never forgotten is how dynamic and focused on shipping and building for our user base that culture was. That first week and that culture that I learned at GitHub is why PlanetScale exists. Because we had to not only ship and scale a product that every user in every developer in the world ended up using at 100 million developers. That's more developers than pretty much any analyst would say exists in the world. But we had to do things quickly. Like GitHub deployed then, and I'm sure still in incredibly impressive numbers, like 100 times a day. So we had to build infrastructure that caught up with these incredible developers that were building experiences for our user base, a demanding audience of developers, but we had to do it stably. And that was an incredible challenge. And it was the learnings from that is why PlanetScale exists, because we do the same. We ship incredibly quickly at PlanetScale. At the same time, we want to get out of the way of our users. And so we want them to ship incredibly quickly while on top of very, very stable infrastructure. Yeah, it was an incredibly special time. And I did also break the website. No, I've said that.
When was that happening, more or less? How long ago was that?
What do you mean, when I joined or when,
Yeah, kind of. How long ago you were, shipping something 100 times a day?
Oh, I think they were doing it from the very beginning when the company started in 2008, and it never really changed. That was a cultural precedent that was never meant to change.
The reason why I'm asking is that I'm still hearing to today, speaking with different organizations, hey, I cannot ship every day because that's a new thing happening right now. I'm not yet ready. That's why I usually ask people, okay, when were you doing it, right? Because it's not something that started happening now. It was happening in the past. It's just not necessarily with many of us.
It's excuses. It's excuses and not leveraging good tools. We see people talk to us and you say, how quickly does it take to get a schema change in production? They're like, probably 3 to 4 weeks. And there's sometimes they say that proudly. And I'm like, okay. Because there's humans in the way. Unless you are shipping to things that are going to, medical devices or aeroplanes or whatever, if you're shipping SaaS software, you should be able to deploy many, 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 many times a day. And you should find the reasons you can't and eliminate those reasons. But you should not give yourself any excuses.
Even if it means eliminating humans, giving you the excuses?
Yeah, right. That's maybe step one.
Okay, going through your story there were a couple of things that jumped out at me. So it's 2 questions. So we'll start with the first one. When you left GitHub and started PlanetScale, what were the culture items that you took directly from GitHub and planted in PlanetScale day one?
So first of all, I'll say I didn't start PlanetScale. I joined PlanetScale early in their journey, but I joined to run the product team and then eventually became the CEO. But we completely redid the product, except the back end. Except our back end has been around for a long time, and that's what we used at GitHub, and that's how I came in touch with it. But culturally, we started with shipping constantly and then demoing our work every single week. That was the first thing we did in the early development of the product, which is we were going to say what we were going to do. We're going to call our shot, we're going to hit it, and we're going to show the organization. And that had so many downstream effects. It brought the whole company with us. We built with a very small team at the beginning, and we had to show where we were going. So we built very, very simply, picked very, very simple user stories, and just delivered on them, demoed, and week to week, you could see the application evolving in front of our eyes. And then within 6 months of the first line of code, we had a product out in beta for our users to see and consume. And then later that year, we released it in GA. But the cultural pieces were, let's build the infrastructure that allows us to safely deploy and ship our application constantly. And then let's then really understand our users, understand what they need, and build from there. If you iterate and you ship quickly, then no decision is that consequential. If you have a 3-month development cycle, you not only better be good at software engineering, you better have a crystal ball, because you better be right with that shot you've just called. If you can ship constantly and make it like a spread bet almost of like, I'm going to try this, put it in front of a user, they like it, they don't, unship it, do it. If you can ship that way, you don't have to be right all the time, and you will find incredible and delightful things about not only your product, but how people view your product.
The second question was, how do you ship serverless? Because is it serverless functions? Is it containers as a service? What does serverless mean to you today?
So for us, serverless is really just the model and the way we expose our product to our users. We don't ship on serverless functions. We still have like a very large sort of stateful backend that runs on Kubernetes. For the dev, a lot of DevOps folk here will be very familiar with Kubernetes. For tests, which is our backend, is not only one of the oldest Go apps, but was also built on Borg. So it's Kubernetes ready before Kubernetes. And so it's very, very comfortable running an environment which is very ephemeral and where servers go up and down and pods disappear. And so that is how we give people that service experience where they don't think about the topology of their cluster. They don't think about whether nodes are up, nodes are down. They don't think about nodes. They think about, can I reach the database? Is it doing what it's supposed to or not? And that makes lives of our users incredibly simple. Like, it's great to kind of catch up with customers and have them say, we literally have not thought about databases since we bought the product. Like, that is the serverless experience. That is the, like, building software less the headaches.
I mean, if you think about it, you sit down with the MySQL CLI, that's the only thing you should care about is, can I connect? Can I query? Can I disconnect? I still need a host name. I still need credentials, unless you've magically been able to get rid of those two things. Now, if you can get rid of host names and credentials, that would be amazing.
Yeah.
Okay, we know we can't do that.
Although, back in the PHP admin days, people were running without credentials.
Yes.
And they found out why maybe having credentials.
That's a good thing. Credentials are a good thing. Yeah. Kids don't run without credentials. Okay, so let's go back to that first week again. What caused the database to go down? What caused you to bring the site down? I'm assuming it was a database problem.
It was, yeah. Yeah. Which, I mean, I think you can chalk many of the world's outages to database problems, right? We had a schema change to do. I joined, I was the first database engineer at the company, and hadn't ran schema changes for a while. And there's connections into this story and a lot of things in our product. Schema changes are tough, right? If you look at Mongo, like why Mongo took hold in the early days, it's because they didn't require you to make schema changes. It was a huge miss for MySQL to make schema changes that difficult for so long. It's like, okay, so we have a schema, we want to add, remove columns. This should be really easy, but it was a blocking operation. It was, really a complicated thing to do. And we still meet customers that are like, we haven't migrated our schema in a year because we're scared of it. We just add to it. We don't take away, or we don't optimize because of how hard the process is. And so I went and used a common tool called PT Online Schema Change, which allowed you to do online schema changes against the database. I go and run it, and I run the schema change. And the developer, great, absolutely fantastic developer, had missed where we were accessing a certain column, and he wanted me to remove these columns from the database. We were kind of tidying up some models in our Rails app, and I went and removed that column. And then the website went down. Everything was erroring, like failure on a query for this missing column. And so the whole of github.com was down. So I had to reapply the migration, get that column back, which we'd lost the data at that point. We had it in backups, but at that point, getting the website up online is more important. That data wasn't worth restoring from backup. And then we have disparate sets of data that's been written in and then in the backups. And so it was a very nasty story. It took about an hour to get the website back up online. And this is one of the reasons that, that wasn't the first time it happened. It happens a lot. We meet people all the time that cause outages like this. And it's really because they can't roll back their database. So, part of DevOps is continually deploying, but you have to be able to roll back some of your deployments. And if you apply a schema change as part of a deployment in your database and you can't roll that schema change back, you don't have that full DevOps cycle. So one of the things we built at PlanetScale is PlanetScale Rewind. And so it works within this bigger framework that we have called deploy requests. We were the first database platform to ever come up with database branching or database deploy requests. And very telling that GitHub people came up with this, but we allow you to branch your database and then change your schema on that branch and deploy your schema from that branch. So we take a look at the delta between the main branch, which is your production database, and the development branch that you've created. And we add or remove the columns to converge on the state of that branch. And if you say drop a column that you need, you can now just hit undo, which will undeploy that change. The data comes back, the column comes back. And if I'd had that on that day, it would have been a less than a minute outage and it would just moved on with the day. And this is why we can deploy so quickly, because we obviously use this. And so our goal is to make, in service of constant deployments for our customers and constant iteration against the database, which is the slowest moving part of the stack, we've made it so that you can just arbitrarily deploy database changes as if they were code, and then make sure that's not a one-way process and roll it back. And we were excited about that. This is all world-first technology. We're the only company who's successfully achieved this so far.
And on MySQL, nonetheless.
On MySQL. It's funny, right? What's old is new again. I mean, obvious choice, but yeah.
To me, that's curious, right? Until not long ago, we had the whole NoSQL, nobody would use SQL databases anymore, right? And I have a feeling that we are back in a different shape and stuff like that, but we are back to essentially MySQL and Postgres, right? Those are the two databases now.
Yep. And this new era of cloud, new era of serverless means in the long run, it doesn't also matter so much, right? You're coming to us for like a great database experience, all these other cool features. If we run MySQL under the hood to get that done for you, I mean, does it matter? As long as it's great.
I was about to ask that question, right? If I consume a database as a service from somebody and you tell me that, okay, this is the MySQL, it works with MySQL SQL drivers, right? From that point on, I don't really care whether you're running MySQL or something else, as long as the API is what I expect it to be, right?
MySQL being very operable makes delivering what we deliver for our users much, much easier than it would be building on top of other databases.
Why is that?
When you compare it to Postgres, it's the origins of the two projects. Postgres was an academic project designed to kind of teaching people pure implementations of SQL, and they've backed it into being a real database, and they're still on that journey and not there yet. I mean, Mongo, a fact that blows people's minds is Mongo existed and allowed you to do like proper clustering with replication before Postgres had proper replication. So it's on a very slow journey to becoming a real database, where MySQL was founded as a project with a company backing it to be a highly operable, scalable database for developers. So those origins in design, the MySQL replication protocol and how MySQL does replication is so mature. You can trust MySQL replication with your life. Like, people use MySQL replication for inter-data center streaming at massive scale. Like, it is just so robust and so trustworthy. And the operations of MySQL, it's so easy to operate in comparison to other databases. It's a great starting point. And it is why the majority of the internet, and I'm saying the majority, still runs on MySQL, because it's the thing to operate. You look at the top 100 of the internet, barely any of them don't use MySQL in some shape or form. Graph databases are a hot thing. At Facebook, Tau, the world's largest graph database, runs on MySQL. Like, it is just the kind of foundation of the internet. 70% of the internet still runs on PHP. And you've got to imagine that 70, to be very conservative, 75% of that runs on MySQL. It's amazing because it's just extremely operable. And at the end of the day, other companies outship MySQL with fanciful features, but they're the ones that lose you customers when you go out for a day.
But then MySQL was purchased by an unnamed company, by somebody that drives big boats.
Mm-hmm.
Doesn't that concern you just a little bit?
Well, they've owned it for a very long time now, and it's only got better. Contrarian take is that they're very good at databases, and InnoDB, thanks to Oracle, it's a modern marvel of engineering. InnoDB is probably one of the best and most stable storage engines ever. Thanks to Oracle, we have it. They've been good stewards. There was a lot of doom and gloom about them buying it, and it hasn't really played out that way. I mean, even now it's proprietary, but stuff like HeatWave is also really impressive. They do know databases. The team that is behind it is still there. They're still very good at what they do, and it hasn't really caused many problems.
Are you using InnoDB under the hood for PlanetScale?
Yeah, it's the standard pretty much. It's been the default storage engine now for MySQL for a very long time. MyISAM really doesn't do much now.
If you weren't using MySQL today, what would you use? If you were to completely retool PlanetScale today, and let's say MySQL did not exist, would you stick with a relational? I'll take it a little higher level. Would you stick with relational? Or would you go more towards a document store? Knowing what you have to scale at.
Yeah, it would still be a relational database. It would have to be for what we do. And the downsides aren't there as much anymore. It'd have to be Postgres. We wouldn't be as happy about it, but it'd be the closest. It's closer to what MySQL provides, but it'd be tougher and be much harder to provide the level of service we do.
And you've been speaking specifically of MySQL. Where do you fall on Maria?
Again, it's in them. I can't. In my answer, I wouldn't call them two separate. There's now compatibility issues between the two, and they have diverged in terms of the roadmap. But the foundations are pretty much very, very similar. They've just kind of gone in a bit of their own direction. If Maria was a choice, it would be Maria because it's then closest to MySQL. The replication is probably nearly identically the same. But so yeah, like Maria is like just a kind of fork with some changes, but not wildly different.
Again, the story seems to mirror back to the Oracle purchase of MySQL, all the doom and gloom that really hasn't fully materialized. Much like when Microsoft purchased GitHub, and the doom and gloom did not materialize either, or at least not that I've seen. Again, I'm sure there's parts that have happened. I mean, just because, but anytime you have an acquisition, stuff happens.
If you're a GitHub user, it's continued to be a great product. I mean, you've got Copilot now, you've got lots of incredible things that have come since the acquisition.
Exactly. I mean, I would say that there was that initial doom and gloom, everything is going to hell, but from the user perspective, Microsoft buying GitHub sounds like actually beneficial for everybody. You just said it, like Copilot and quite a few other projects that probably wouldn't materialize, at least not that fast, right? By GitHub alone.
Yeah.
So I want to go back to Rewind for just a second before we start wrapping up. How would you recommend somebody test out Rewind for their very first time using Rewind? What would be the right way to onboard somebody to Rewind?
So get your database over to PlanetScale, get it moving. And the great thing about it is because it really just does undo, the consequences of using it are quite small. I mean, there isn't really any negative consequences to using it. You could go and deploy that one change to your schema that you've wished you could add for a long time, or that table that's really complicated and precious, and go and roll that change into production and then immediately undo it. You can just bounce that change straight out of prod and your application keeps working the way it is, and you're just happy you don't have a long outage to deal with.
I'm sorry. I think I'm going to be a little... I don't believe you. I'm sorry. I have to try it out for myself because it just seems too good to be true. Like dropping columns is easy. Bringing columns back is easy. Where you got me is and the data.
Mm-hmm.
That's where I'm like, okay, this just seems too good to be true. Especially when you say immediately. And I know that immediately isn't, split second. But within breathing time, it's like, wow, that's pretty darn amazing.
Yeah, it's about a second. When I got the first demo of this, I didn't have any feedback. Otherwise, I just started laughing because this is a dream thing that I've wanted for years. And to see it working was amazing. When we launched it, we actually took a customer onto a live stream and dropped one of their production columns and then brought it back for them because it's too good to be true. And we get that feedback. It's so funny you said it that way because I was on a call. We catch up with the sales team and forecasting. And there was a customer that said, I looked at your marketing and I wanted to disbelieve it. And I've tried everything I can to disqualify your marketing. And we love it and it works. And so this is a new challenge we have. Everything that's been said in the world of databases can be said, and as it has been said, and now we actually have to kind of just get it into people's hands and show them that it does these things. These are all things that people assumed would never be solved, but we've kind of got there and done it.
The way I translate that feature, let's say, right, is not necessarily, I can revert a mistake, but I can drastically increase the velocity of developers, right? So it's not that if it ever happens once in 3 years, right, I can do that. But we can just go as fast as we need and we have our backs covered, right?
Exactly. When we were doing user research in the very early days and when I was meeting customers and talking to them about schema changes and the problems they face using a database, because one thing we were really clear of is like, not only do we have the back end that ran YouTube, it was built at Google, ran for 2.5 billion users. We have all of those stuff. That's database scalability. But we wanted to get into the lives of developers. We wanted to find out what are the database problems that plague people daily. And schema changes is one of the biggest. The word fear came up in relation to schema changes constantly. We're too scared to touch that table. We're too scared to refactor this. Every time we've tried, the database goes down, or we just don't know. And we really wanted to take that fear away. And we have just turned it into something just feels so easy to do that you unblock people. Our own developers, it's so funny. Our own developers like, my God, I'll never be able to work anywhere that doesn't use this because you just move so fast. And someone asked how PlanetScale shipped so quickly. And my honest answer was, well, partially we can ship 5-10 schema changes a day and it doesn't matter. And that genuinely unblocks people massively.
So with database as a service, I pay for what I use. You guarantee certain SLAs, I assume, right?
Yep.
I can reverse stuff. How big of a need do we have then for dedicated DBAs in a company?
It's an incredibly talented set of folks that go and do this work, but I think they're needed more in terms of these very bespoke. You're finding them now in much larger deployments that are much more bespoke to manage very large stacks. I think the time at which a company needs to hire a DBA now is changing because of this and tools like this. You for majority of people, you don't need them. It's like a lot of jobs, right? A lot of sysadmin roles are just gone because of server provisioning is so easy. It's just changing.
Because if not, I'm pretty sure we are not eliminating DBAs, but I guess the need to, every time I want to make a change to my application that requires some change of the database, I need to ship it to John. And John is a bespoke DBA that needs to bless it and all this stuff, right? The dynamic must be changing. Not necessarily the roles.
Mm-hmm. Oh, definitely.
Kind of this role is not needed anymore, but how different roles interact with each other must be different.
Definitely. And that's great. Technology should do that for us.
So PlanetScale can be found at planetscale.com. Sam's contact information will be down in the show notes. Sam, thanks for being with us today.
Thank you so much for having me. It's been really awesome to be here.
We hope this episode was helpful to you. If you want to discuss it or ask a question, please reach out to us. Our contact information and a link to the Slack workspace are at devopsparadox.com/contact. If you subscribe through Apple Podcast, be sure to leave us a review there. That helps other people discover this podcast. Go sign up right now at devopsparadox.com to receive an email whenever we drop the latest episode. Thank you for listening to DevOps Paradox.